Hi, everyone, and welcome this afternoon. We have today Programmable Networks, Software-Defined Networking with OpenFlow webinar. Today's speaker is Paul Ruth. He is a senior research scientist at RENC at UNC Chapel Hill. He is a researcher in the Network Research and Infrastructure Group, and he's been a core contributor to the Exogeny testbed. He's currently a co-PI on the NSF Cloud Chameleon testbed. He earned his PhD degree in computer science from Purdue University in 2007. Chameleon's Bring Your Own Controller, or BYOC, functionality enables tenants to create isolated network switches managed using OpenFlow controllers provided by the user. This feature is targeted at users wishing to experiment with software-defined networking, as well as users with experiments that have non-standard networking requirements. Today's webinar will demonstrate how to use Chameleon's BYOC capabilities and provide tips and tricks to getting the most out of networking experiments. Participants will be able to follow along using a Jupyter notebook that is included in the standard Chameleon Jupyter environment. During this presentation, please type general questions in the Q&A box. Members of the Chameleon team are on the webinar and will be answering your questions. Thank you. Welcome, Paul.
Hey, hello everyone. Like Stephanie said, today we're going to be talking about how to use some of the OpenFlow capabilities of Chameleon, and hopefully this will get you started. I know there's quite a few people that have signed up for this webinar, so try to follow along if you're interested in doing the tutorial live with us. Go ahead and do that. Although there will be quite a few people doing it, so bear with this system. We're just going to jump right in. If I can forward my slides somehow. Okay. So, I mean, a lot of you are probably familiar with Chameleon in general. This is a slightly more advanced webinar than the intro webinar. But just for a little background, this is what the Chameleon hardware looks like. This was actually the phase 1 hardware looked like this. So the idea is there's 2 sites, one in University of Chicago and the other in Texas Advanced Computing Center in Austin, Texas, the University of Texas. In Texas, there's in Texas there are 10 racks of computers, or there were in the first phase anyway, 10 racks of Haswell computers where there's 42 compute nodes and 4 storage nodes. And these are standard computers that you can use in a bare metal style. In Chicago, there were 2 racks of computers like this, and they were both connected to the Chameleon core network, which is a 100 gig per second uplink between. Of course, you all the infrastructure that we have available. So you have GPUs and FPGAs and SSDs and InfiniBand and ARMs and Atoms and low-power Xeons and various things like this. During phase 2, and this is important for this particular webinar, we added some specialized hardware to do more interesting networking features, and you can run networking experiments on it. And in this case, we added 2 racks of Skylake nodes in Chicago and 1 in Austin. And these racks of computers are specialized, not just in that they have the more advanced Skylake Xeon processors, but they also have at the top of the racks these specialized Corsa switches, which allow us to create isolated OpenFlow switches for the users. And we'll get a lot more into that later, so I won't go too much into it right now. But just know that if you're doing the OpenFlow experiments, you have to use these Skylake nodes, not the Haswell nodes, because the Skylake nodes have the Corsa switches. We do have plans to try to make the Haswell switches the Haswell nodes use OpenFlow, but that's not deployed quite yet. Also interesting that what we added in phase 2 was the ability to create layer 2 circuits, both between the 2 sites, but also externally to things like Genie and other future partners. We actually have done some demonstrations where we connect to Amazon EC2 instances and Google Cloud and Microsoft Azure. And if you're interested in that, talk to us about that. So So let's talk about OpenFlow. So in these particular racks that we have, there are these switches that we have that in the racks that have Skylake nodes. They are made by a company called Corsa, and they're the DP2000 series switches. So we have some of the various levels of them for various reasons. But what they allow us to do is they have sliceable network hardware. So what this does basically is these are OpenFlow switches, but they don't behave like normal OpenFlow switches. Their native way that you interact with them is to create isolated, what they call virtual forwarding contexts inside the switch. And so in effect, what you're doing is creating different ports on the switch and connecting them to a virtual forwarding context. And these virtual forwarding contexts, each are OpenFlow. They behave like a logical OpenFlow switch, and they run OpenFlow version 1.3. And what this allows us to do is for each of our users that want to do this, they can each create a network that will be implemented as a virtual forwarding context on the Corsa switch. And we will be able to connect an OpenFlow controller that the user deploys and the user has full control over, that will control this virtual forwarding context. So in effect, what this does is allows users to have their own OpenFlow switch that's connecting their Chameleon nodes, and they can do anything they want with this OpenFlow switch, anything you can do with OpenFlow version 1.3. And because this is done in these Corsa switches, and it's the native way that these Corsa switches work, everything works at line rate as if it was a regular OpenFlow switch. So you have 10 gigabit ports to your nodes, and you have a 100 gigabit uplink port, and you can get that kind of performance. So the way they're deployed, we have two sites, like I said, one in Austin, one in Chicago. There's 2 racks of computers in Chicago that have this capability, and one in Austin. In Austin, we have a DP2200 at the top of rack, and in Chicago, there's DP2400 because they're actually linked together and they behave as if they're logically one switch. And what this means for you is that you can have nodes that are on different racks on the one node on each of these racks, and they can be connected to one logical OpenFlow switch, even though they're connected to 2 separate OpenFlow switches. So to you, when you deploy your OpenFlow switch and controller and a set of nodes, you don't actually care which rack it's on. And this is a complicated thing that we made work here. Yeah, so that's what this is about. So what does this look like? Like, how do we do this? How do we provide, what do we provide to the users? So inside a rack of computers, these Skylake racks, or these racks with Skylake nodes, we have these Corsa switches at the top of the rack. And what we can do is we can allow, and I've kind of mentioned it already, we can allow multiple different tenants or users to create their own virtual forwarding context in the switch. And we can connect to those virtual forwarding contexts OpenFlow controllers that the tenants deploy. Now in this picture, the controllers are both deployed on Chameleon, and that's probably a pretty good place to put your OpenFlow controller. But there's no limitation of having it be on a Chameleon site. You can actually deploy the OpenFlow controller anywhere that's accessible on the internet. So it could be on your laptop, it could be at your institution, it could be anywhere. So then what you would end up with is a virtual forwarding context for each user, isolated by the Corsa isolation mechanism, controlled by your OpenFlow controller, any type of controller you want. We're going to do an example today where we use the Ryu OpenFlow controller, but you can use anyone you want. People use OpenDaylight, people use whatever controller they want. You can even write your own, make up your own controller, although that's becoming more and more difficult to do. And then you can connect your nodes to your switch and have the OpenFlow controller control how the switch behaves while your nodes are connected to it. So this is the basic thing that we enabled using these Corsa switches. There's a couple more complicated things that I'm not really going to get into today, but we have talked about at different webinars in the past. And if you're interested, you can contact us and we will show you how to do this. But we can actually create, if you had nodes in Chicago, as let's say this yellow user here, tenant B has some nodes in an OpenFlow controller in Chicago, and then some nodes in an OpenFlow controller in Austin. We can actually connect them together with layer 2 circuits. So you can have basically 2 routers. You can implement 2 routers that actually are on 2 different sites, 1,000 miles apart or whatever it is. I don't know if that's 1,000 miles, but it's a lot of miles. And at the same time as that's all happening, some other user can have their own VFC that's completely isolated. This mechanism uses exogeny to do this, and you can use this exogeny to connect to either the 2 Chameleon sites, or you can connect into your campus or anything where Genie connect to on Internet to L2S or various other things like this. So, and we call this stitching, or Genie calls this stitching, which is creating isolated layer 2 circuits between multiple sites. So now I'm just going to get into the tutorial. So like this is what we're doing, is we're going to show you how to use some of these mechanisms, not the stitching part because that's in a different tutorial, but this is basically what we're going to show. So how do I do this without screwing up the thing? So if I go over here, I can't see my screen. So you should have, if you have an account on Chameleon, you can go to jupyter.chameleoncloud.org and log in a Jupyter Hub container that is isolated, that is for you. And if you haven't created one yet, it'll create one for you automatically. And when you do this, it'll automatically check out a bunch of notebooks that we've written for various tutorials. You'll have a folder in your container called notebooks. And if you click on that folder, there's some tutorials. And then if you click on networking, inside of networking, there's the one that I already have open. It's called Bring Your Own Controller. So this is how to use OpenFlow networks. And you'll see it right here. This is the tutorial. Let me see if I can make that even bigger. That's as big as it'll let me make it. So we're just going to go through this tutorial. I've actually already started it a little bit because it takes like 10 minutes to create a node, as you all probably know. So I did the first one earlier, so we don't have to wait that 10 minutes. But what this does, you can just a side note here is I guess there's 28 people logged in right now, which 28 people should be able to do it all together. So I'm not going to give you the warning that you might not be able to do this because there's too many people. You should all be able to do this with me if you want. You should all, there's a note here, you should all have been added to the tutorials project. So if you look when you log into your, let me flip over here to this. If you log into your, where's the overview? I'll just make it overview here. When you log into Chameleon, the Horizon interface to Chameleon, or the GUI for Chameleon, if you click up here, you see that I have a whole bunch of projects that I'm part of. You typically will only have one. If you have been in one in the past, you probably are in 2 now. If you go down to the one that ends in 0156, that's the tutorial project. And you probably want to do that because I currently have reserved in that project all of the Skylake nodes. So, and this is so that anyone who's doing this webinar should be able to have access to Skylake nodes. But they're all reserved in that project. You can use either TAC or Chicago, it doesn't matter, reserve them all on both sites. So go ahead and flip over to that particular project and you will be able to use it. I'm gonna stay on my regular project because I have a few nodes that are reserved there, and that'll keep you guys out of my way.
What about people who aren't part of projects right now?
If you're not part of the project right now, then you can follow along and watch what we're doing. Contact us afterward, and we will get you hooked up with the project. And you can go through this Jupyter notebook on your own later, and we will provide both the slides that I had, as well as a link to the Jupyter notebook, as well as a video of what we're talking about right now. Feel free to ask questions, and we'll be able to answer any questions you have. Okay, so let me get this out of the way. I have this like bar on the top that's in my way. Okay, so we'll go over back to my Jupyter notebook. What we're going to do here, there's the basically steps that we have here. We're going to create an OpenFlow controller on Chameleon. We're going to create an OpenFlow network that's connected to that controller. We're going to then create some nodes that are connected to that network. And then we're going to observe and modify the OpenFlow controller as connected to the network and just kind of see how you might interact with it. If while you're doing this on your own, you have problems with things, some other information that might be useful is the Getting Started tutorial or the Networks and Isolated VLANs tutorial, or setting up the CLI, for example, if you're trying to do this not in a Jupyter Hub notebook. The next section is a little background on software-defined networking and OpenFlow. It basically talks about how when you have an OpenFlow network, you have to have a controller that controls it, and hopefully you guys are all interested in learning about software-defined networks or have some advanced networking experiments that you want to deploy that needs a fancy network. So, at the end of this tutorial, what you should have is an OpenFlow controller that is optionally hosted on Chameleon. In this case, it will be implemented or hosted on Chameleon, although when you're doing this, you can host it wherever you want. You can put it on your laptop if you want or anywhere. Although doing it on Chameleon is probably the suggested way just because it's, why not? There's free nodes that you can use. You'll get your isolated network switch inside the Corsa switch, and we're going to create two nodes that are connected to it, and we're going to log into them and ping between them. So the way this works, hopefully everyone's a little bit familiar with Jupyter. If not, there is a Jupyter webinar that we did a while back. You can go back and check out the Jupyter webinar. But basically the way Jupyter works is there's these boxes here, and in this case it's just bash. It's just bash scripts that you can write, and then you can execute each of these scripts in this isolated environment. For you, when you're doing this, you'll need to change this environment setup at the top to put the ID number of the project that you use, and the site that you're targeting, and SSH keys that you should have you should put in your Jupyter environment, so that you can have the scripts SSH to your nodes and you can configure things. We can get back to that, and you can figure out how to do that a little bit later. And then you also have to have two or at least one reservation already set up. So keep in mind that let me go back up to the picture. The compute nodes here have to be connected to an OpenFlow, one of the Corsa switches. So these compute nodes have to be on on the Skylake racks. So when you make a reservation, make sure that you choose the Skylake nodes, so that you get ones that happen to be connected to the Corsa switch. Now the OpenFlow controller can be anywhere in Chameleon or anywhere on the internet. You could also put it on a Skylake node, and that's perfectly fine. But if you want to, you can put it on a Haswell node. If you want to use one of the nodes that's in less demand, that's recommended. But you can also put it on a Skylake node. It's no big deal. So in this particular environment setup, you want to put the reservation ID of where you want to put the controller. So in this case, I have a reservation for Haswell nodes, and I'm going to put the controller on a Haswell node. And I have reservations for the nodes, and those have to be on Skylake nodes. So this reservation is for Skylake nodes. So if I want to look over here at TAC in my project, and if I go to reservations, you can see that there's a lot of reservations in my project because all sorts of people are using them. But there's two of them. One says pruth Skylake, and the other says pruth Haswell, and those are the two nodes, the two reservations that I'm using. So then you go down here and it says you want to create the OpenFlow controller. So what we're actually doing is creating a node that's running on Chameleon that is going to be automatically configured with the OpenFlow controller. And we're going to do this using this with a stack. So we're going to do it with a heat template. And if you can use the same thing. So if you go here, if you've been to the appliance catalog, so if you go to the main Chameleon site, you go to appliances, you should be familiar with these appliances a little bit. These are templates that will automatically boot and configure sets of nodes or complicated nodes. And one of the templates in here, if I find the right one, I don't know, maybe it's on the last page, is this Ryu OpenFlow controller. And if you go to this Ryu OpenFlow controller, you can see the template, the heat template that it would execute. There's also some documentation that says how to use it. And we're basically going to deploy one of these Ryu OpenFlow controllers, and then we're going to create a network or an OpenFlow switch that is going to connect to this controller. All right, so hopefully that makes a little bit of sense. And so here I'm just like making some names for my stack, name for my controller. If you use $username, it gets your username. So mine are going to be called pruth_controller_stack and pruth_controller. I suggest you do something similar because you're all going to be using the same project. And if you look at the list of nodes, if your username is in the beginning of a few of them, you know those are yours. If everyone names them the same, then you won't know which ones are yours. So you should probably do something that identifies them. Your username's a good one. The controller, this is the network the controller is going to use. Like, keep in mind that the controller is going to be connected to basically the internet. And it does not have to be connected to the fancy OpenFlow network that you're about to create. In fact, you shouldn't connect it that way, because then you could easily cut yourself off from the network. So you want to use any network you want. You could use a private VLAN if you wanted. I'm just going to go ahead and use the basic shared net because that also works, and it's just easier to configure. So you should probably use that at first, but you might want to use a private VLAN eventually. It's up to you. And then you can choose the OpenFlow port that you want to use. In this case, I'm using the default OpenFlow port of 6653. But if you want to customize it, you can customize it. But there's not really any need to do that. Then this is the command. So one of the interesting things about these Jupyter notebooks is you can use them as examples for all sorts of things. So this is, for the purposes of this tutorial, this is how to create an OpenFlow controller. But it's really an example of how to use an OpenStack heat template on Chameleon. So in this case, you say OpenStack stack create. The with thing is so that it prints nicely in the Jupyter notebook. You can leave the with out. The template, here's the path to the template that I just showed you. So this is just the URL to this. I go back to appliance details. The URL to this template that is here. You just cut and paste this template into here. And then this is the key you want to use, the reservation you want to use, the port you want to use, the network name, the controller name. I'm saying wait, so I'm saying wait until it's finished before you move on, and then you name it, and there it is. And I've run this earlier, so this is the output of it. It takes about 10 minutes to boot a node, so that's about how long this took to create. And if we go to my set of instances, we should see there is a node there. And this is my pruth_controller node. It should have OpenStack running in it, or OpenFlow controller running in it. I'm going to take the public IP, that was automatically put on there, and I'm going to find my terminal, which I should probably make bigger because everyone was complaining. Make that bigger. All right, that's probably too big, but whatever.
That looks good.
Okay, cool. So then I can SSH to the IP address that I just copied out of there. And you see here now I'm in a node called pruth_controller. Of course, I have to SSH to CC at that IP address because that's what you do with all Chameleon nodes. We can look here in /var log Ryu manager log, and this is the log that the OpenFlow controller is going to write to. And right now there's nothing in it because all we've done is boot the node and we haven't connected any switches or networks yet. So this controller is just sitting out there doing nothing, waiting for the controller to connect to it, right? Or waiting for a switch to connect to it, but we haven't connected any switches yet. So I'm going to leave this sitting here, and we'll come back to it. Maybe even I make my window a little bit narrower. Hopefully the Jupyter Lab part fits in there. I wish I could make that disappear. That's all right. So now we're just going to continue in my Jupyter notebook, and we're going to create the network that is going to connect to this switch. And we should be able to see things start appearing in that log as things are created. So the next thing I do here is, this is just to get the public IP of that node. So if I run this command, it's going to contact, it's going to say OpenStack server show, format address, get the address of the controller node, and then use some bash magic to pull out just the IP address. And now I have the IP address stored in this variable that I can use later in this particular Jupyter notebook. So you can see the public IP is this, which is what I logged into over here, right? In this case, the next cell, they call it, just does exactly what I'm doing over here in this terminal permanently. It's logging into the controller, and it's just showing the last 20 lines of the log file that we're looking at over here. You can do that if you want, but we're just going to have it in this terminal running in the background all the time, which I find a little more convenient. Okay, so the next thing we're going to do, so at this point we have our OpenFlow controller running, but no networks or switches connected to it. Next thing we're going to do is we're going to start creating OpenFlow switches. So in OpenStack, there's really no idea of creating an OpenFlow switch. They have this idea of creating a network. And what we're going to do is create a network, and we're going to pass in some special description parameters that is going to trigger Chameleon to create a virtual forwarding context on the Corso switch for you, and point that virtual forwarding context to your OpenFlow controller that exists anywhere on the internet or on Chameleon. So what we're doing here is we're going to say create a network, and we're going to say the subnet we're going to use is this subnet. You can put any subnet you want there. This is just a standard one that is available. We're going to have some names for the network, the subnet, and the router. And if you have used the isolated VLAN and isolated networking capabilities of Chameleon in the past, you'll know that when you create a network, you have to create a subnet and a router on top of it so that your network can then connect to the internet and has the appropriate subnets. This is just exactly the same as using the regular Chameleon networking. It's no different, the isolated networking. And here we're going to write a name for the switch. So this is a thing we can do. I'll tell you a little bit why we want to name the switch here in a minute. So let me see if I make this a little bit wider, this will all fit maybe. I don't know. I'll make this wider for now so we can see what's going on. So the command to do this in OpenStack, the command to create a network is OpenStack network create. This looks a lot like any other network you created on Chameleon. So it's, and the max width just makes it so that it fits nicely in this Jupyter notebook, but you don't necessarily need to do that. Provider network type, you say VLAN. This is a little weird because it's not actually going to make a VLAN. It's just going to make a switch. There's no, like I said, there's no content. There's no OpenStack notion of a switch. So we're using the VLAN notion for this. We're going to use FizzNet1. So FizzNet1 just means create a network that only connects to things inside of the one site. If you want to connect to exogeny or something external stitching, you could use you could say exogeny here. There's other tutorials that talk about how to do stitching, and they work just fine with the OpenFlow switches as well as the regular switches. And the difference now between this and regular networking on Chameleon is this line right here. So what we're going to do is we're going to pass a description, and this description is going to have a couple parts. The first part is you're going to specify the OpenFlow controller of this network, and it's going to be the controller's public IP. So you can just put the IP address here, but keep in mind, so controller public IP, I got that up here. You scroll back. I got that from querying the address of the node that I just created, right? So if you're using your laptop or you're using some static node in your institution, you can just put that IP here. But what I did is I created this node that we're watching in the background here, and we're going to use that IP. And I had the Jupyter Notebook actually get the IP for me, which is pretty slick. And then I have the OpenFlow port. And if you remember up here, somewhere I said the OpenFlow port was 6655. And when I created my stack, I passed in the port. So now we know that this OpenFlow controller is using that port. And now we're about to tell this OpenStack network to connect to the controller that's at this IP and this port, which should be the node that I created earlier. I'm also going to name the switch. And this is just a name that you can use in Chameleon to access this switch later. And what this is useful for is connecting, for stitching mostly, for connecting a bunch of VLANs to this switch, a bunch of like uplink ports to it. For this particular tutorial, we're not going to do anything with that, but we will. This is how you name it, and you can then just refer to it later. If you look at the stitching tutorials, this will make a little bit more sense. And then when you create this, there will be a primary uplink VLAN. So this will be the VLAN that is used across the one Chameleon site to link all of your nodes together, all the nodes that are not physically connected to this OpenFlow switch. So there'll be one uplink to the rest of Chameleon and the OpenFlow switch that's connected to a bunch of nodes that you've created on that switch. So let me go ahead and just run this. And so now it's creating the network. Why did it not work? Is it because I tried to do things? Oh, it's because I didn't run this step first. You got to run all the steps. If you don't run all the steps, it won't work. So I didn't run the first step to configure my switch names and things. All right. So now it should work, and it's going to create the network. And you can see this is it creates a network called pRoot network. You can see here that it gave segmentation ID 2203. So this is like I said, the VLAN that is used to connect this switch to the rest of Chameleon. And you can see right when we did this, you can see in our log over here that a port number 2203 was added to our OpenFlow switch. And that OpenFlow switch that is connected to our OpenFlow controller, and it told the OpenFlow controller, hey, I have a new port, it's port 2203. You know, because of that number, that it's the uplink port for your switch. So now we have the switch, and we have one uplink port, and that's all we have. So it's not a very useful switch, but we'll get there, right? So the next step here, it says just look at the log, because it's supposed to show, hey, the port was added, but we're cheating and we're seeing the log all the time. Okay. After that, what we want to do, just like any network in Chameleon, we're going to create the subnet. We're going to create the router, and we're going to link the router to the subnet, and then we're going to link the router to the external network. These steps are exactly like you would do with doing any kind of isolated VLAN on Chameleon. They're no different. You also have to do it when you have a OpenFlow switch. So let's just go ahead and run that. It's creating the subnet. It's creating the router, linking the router to the subnet, and linking the external gateway. And then it says it's ready for nodes. Okay, so now we have an OpenFlow switch. We have it connected to the controller, and we have an uplink port on port 2203 that will allow any nodes connected to this to connect to the different metadata services and the internet and various other things. So basically we have everything except the nodes. And you can even see now we're getting packet ends on our switch, and these are coming from the uplink port, and they're coming from the router that is trying to route for this switch, right? Those will just happen occasionally in the background. So now what we're going to do is we're going to just create some servers. In this case, we're going to create some just basic CentOS 7 servers, nothing special. Using the key that I want to use, using my node reservation ID. So this is, the key is here that this has to be on Skylake nodes. We're going to use the new OpenFlow network that we just created. And here I'm telling it to create 2 nodes because, you know, when you're doing networking, 2 nodes is more interesting than 1 node. And I'm going to have it wait until it's done creating those nodes before it returns. And I'm going to name the nodes preroot-node, and then it's automatically going to name one of them -1 and the other one -2. So let me go ahead and just run this. This is going to take 10 minutes, so I've already been going too slow, and we're almost out of time. We're not almost out of time, but I'm going slow. While this is going, so this is actually going to take 10 minutes. And then while this is going, I'm going to show you a tour of some other things that are related to these OpenFlow networks. So first off, I'm going to go over here to my Horizon GUI that you're all probably familiar with. I'm going to hit instances, and we're going to see a couple more nodes starting to, they're trying to boot. So we can see here that the controller I created earlier, and then now we have the 2 nodes, preroot node 1 and preroot node 2. They're both being built. They're not yet built yet. Once they come up, we should see them added to our switch over here. But this one's going to, like I said, it's going to take 7 to 9 to 10 minutes, depending on how many of you are also hammering on the system right now. So we'll find out. So if you want to look at the network, so we can look at the network topology here. There's on my project, I have a bunch of networks created, but you can see this orange network. Okay, zoom in. I can zoom in. Cool. So the orange network is the network I just created called preroot network. You can see that. I don't know why my mouse is going so slow. And you can see the 2 nodes that are created on it, and they're both in the build state. They should both be in the build state. And they're starting to be built. So you can see that the network has 2 nodes connected to a router. Router is connected to the public internet. And that's what we've created. Let me see if I can make that smaller. Other useful things. So if you go to, in the main Chameleon page, if you go to documentation, inside documentation, you've probably read a bunch of this, but if you go down to networking on the side here, click on that. Then under networking, you go to software-defined networking. It will actually explain to you everything that I'm showing you today, and maybe even a little bit more, I'm not sure. So you can go through here, and you can actually try to run this on your own, even without using the Jupyter notebook. But one thing that's pretty useful that's on this page that you might have to reference is down here in the port mapping. So if you've used OpenFlow before, you should know that every switch has a set of ports. Most switches, let's say you have a switch that has 32 ports on it. It probably has ports numbers 1 through 32, or maybe 0 through 31, or something like that. For these switches, since we want to keep all the ports, or we have a lot of nodes, and a lot of the nodes can be connected to any of the switches. We came up with a scheme for numbering the ports so that they will never interfere. You'll always be able to figure out which nodes are which. So the first thing is up here. Basically says your uplink port will always match the segmentation ID. And we've seen that already because our uplink port was 2203. And that's because these nodes were assigned VLAN 2203 for the uplink. And then what we'll see when these other nodes start to boot, that for every node, so this is Skylake nodes on rack 1 at University of Chicago, I think. Yeah, University of Chicago. And these are Skylake nodes on rack 2 at University of Chicago. And here's the ID of the node. And if you go and look and figure out what nodes you actually got and where they are, the port should match this. So when you're writing your OpenFlow controller or modifying your OpenFlow controller, you can actually use this table to figure out which port is linked to which of your nodes. So if you go back, for example, if I click on, say, this node, see this is node 69BB9. And I don't know, it's at TAC, right? Did it TAC? Okay. Is that number or is it one of them deeper? I think I have to go deeper. So if you go view instance details, physical, there you go. You have to go to physical host name and see how this one is 8B60E999. We should be able to find here on TAC one of these that is 8B. It's this one. So we should see one of our nodes that we're going to see join in a minute is going to be on port 10121 because this is one of our nodes. And that's how you can tell. So if you want to write your OpenFlow controller to know about this, you can do that. So this is very useful, this table that's in the documentation. All right. See how we're getting closer here. How long has this been up? Let's look at instances, overview. This has been 4 minutes, 5 minutes since it's created. So we still have a few more minutes. Yeah. So maybe, oh yeah, we can do this too. I'm going to create a new window here. Let me see if I can make this other one lower and this one bigger. And I'm going to choose the same IP address that I had. I'm going to log into the controller. And here I actually forgot the path to it off the top of my head. But if I know if I go to, let's go to ChameleonCloud.org. You go to appliances, and appliance was on the 3rd page, and you go to Ryu controller, and you go to documentation. Down here at the bottom, it says the log file is here, and this is how to tail it, and the Ryu controller. Oh, so there we go. A port was added, 1021 or 10121, which is the one that I told you it would be. There's another one that's coming, so we're not quite ready yet. So there we got 10122. So they're getting closer. They still have to be a little bit more. So I'll show you one more thing here. So in a Ryu controller, there's something called the OpenFlow or the Ryu app, and all it is a Python file that is inside the system, and the OpenFlow controller is executing this. So what we can do, and I think that this doesn't actually have Vim installed on it yet. So sudo yum install Vim. Yes. And when you do that, and then I'm going to open this file here. And what we have here is this is your, let me put it over here so you can, it makes sense. Basically what this is, if you're using Ryu, and this has nothing really to do with Chameleon, this is just like how do you write, if you want to use our example controller for your own experiment, you can just run your Ryu controller and you can run the Ryu controller that we have available, and then you can just modify this file. And if you see here, which is the basic Ryu controller, and you can do things like, there's some scripts for adding flows, little methods for adding flows and deleting flows. Most interesting thing here is we have this packet in handler. And so this is what happens when a packet comes into the controller. So this is, a packet comes into the switch, and the switch says, I don't know what to do with this particular packet because there's no flow about it. I'm going to send it to the controller. It sends it to the controller, and then this particular function gets executed. And you can see what we're doing here is we just sort of write to the log, you know, packet truncated, or here if it gets past some of the checks, it'll say packet in with the DPID, the source IP, or the source MAC, and the destination MAC, and then the import. So you can see how that, let me scroll it down a little bit so you can see this particular line. And you can see how that matches this packet in that came for this. This is the ID of the script, or the, sorry, ID of the switch. This is this source MAC address. So in this case, it's the router that we've set up that will route to the internet. And then it's the destination is FFFF, which is broadcast. So like my guess is this is probably an ARP. So it's ARPing, and then it says the import, which it came from 2203, which we know is the uplink port, right? And you can see down here, as our nodes were added, the ports were added, ports were modified. You can look in this file, you can see what's doing when it's modifying. And then we can see for this particular switch, there are now packet ins coming from these MAC addresses and going to these MAC addresses. And the sources are, 1021, and there should be a 1023 down here. So what's happening now is these nodes have become available, and they're doing things like checking the internet for things, right? So they have to talk to the router in order to do that. And as this happens, the controller is getting packets from the switch, where the switch is asking what to do with these flows, and then the controller writes back its response, and the OpenFlow controller or OpenFlow switch will do the right thing. So here you can see what happens when there's packet ends. The main thing that this particular controller is programmed to do is to create a learning switch. So basically, every time a packet comes in, it records the MAC address of what came in that port and which port it was, and if it sees another packet with the destination with that MAC address, it'll send it out the port that it saw it come in before. And in this way, it'll learn about all of the different nodes on the switch. Of course, we have 3 nodes on the switch. One is the router to the internet, and then we now have our two nodes that should be created by now. So this is a really simple way to get started with OpenFlow, and I suggest people start with it because it's pretty straightforward. So let's switch back over. We should be able to see now we have our nodes. They're both active. And since you've used Chameleon before, you know that we can't actually get to them yet because they don't have public IP addresses. So what I'm going to do is I'm going to assign a floating IP address to one of them so we can log into it. There's a few already in this project, so I'm just going to use the next one. This you should have seen before, so I'm just going to assign this to preroot node 1. I'm going to associate. And now it should be, if we go back to, not networks, compute, instances. And we take this IP address that's associated with this particular node. And we come over here. Let's create a new tab here. I want to say SSH CC at this particular IP address, which should be one of our nodes. And when this happens, we should see some activity down here. Yeah, so there's some activity. So something came in, a broadcast from 2203, and now we're in. You can see here that this is our node that has this IP address internally. And if you go over here, we see that one of them is 192.168.100.10, and the other is 192.168.100.5. So from .10, we should be able to ping 192.168.100.5. And as soon as I do this, we should see some activity on our switch. And you see that now nodes 1 and 2 are, they've asked the controller for their rules, and they've learned the switch learned the flows. And now from there on out, the controller's not involved, and the switch is just forwarding things, and they're just pinging. So these are interesting things that you can do. This is the basic setup. Like I say, there's 2 nodes, one switch, one controller, and that's the basics of it. If you wanted to do something slightly more complicated, I'll just give you I'll just point towards something interesting that we have in our application or our appliance catalog. There's a security onion one, and I'm not going to get too deep into what it does, but I can draw a picture, or there's a picture down here of what it does. Is it has an OpenFlow controller, and a switch. And in the security onion appliance that's running here, it's actually running a Bro intrusion detection system, and the OpenFlow switch is programmed by the controller to mirror all traffic to the security onion node. So this is something you can't actually do with just a regular switch without programming your switch. And what it does there is, so if node 1 talks to node N by sending traffic, all traffic between those two is mirrored to the security onion node, who can then monitor and look for security issues. The same is true if things are coming from the internet. They get mirrored to the security onion. And so this OpenFlow controller is a special OpenFlow controller that we wrote that does this mirroring. And this is sort of the type of thing that you can do with these OpenFlow switches. Yeah, I think that's basically what we've done. If you've been following along the whole time, you should do these next steps, which is log in and look at the different things. Of course, clean up your resources. There's some scripts here that will run the cleanup for you. And I guess now we just want to open everything for questions for anyone. If someone wants to raise your hand, we can actually I'll answer your question live if someone has an interesting question. Or if you guys, have you been answering interesting questions? Or are there any of them worth me just saying the answer to everybody?
I think the only one that we got a couple of times is how long they'll be able to play in the tutorials project. Or getting kicked out.
As long as I leave it on, you should find a. If you're worried about that, contact us and we'll find you a way to get into a real project, because we really want to know what you're doing. So we want you to be part of a real project, because then you have to write a little paragraph that describes kind of what you're doing, and then that way we can know what you're doing, so we can help you, and also we can tell you about different opportunities and brag about you when we have to write reports to the National Science Foundation, stuff like that. So yeah. So but it'll probably be in there for a couple weeks or more, because I'll get lazy and won't kick you out. But if you get kicked out, contact us and we'll find a way to fix it for you. Anything else?
Yeah, I think another thing that, I can just say, a couple of people have asked if there'll be a recording of this and where it will be. And I did put in chat. So everybody who signed up for this, like who's here in the webinar today, will get an email with the recording and slides and any relevant links that you need. But we also do have a YouTube channel that you guys can check out. We usually post recordings there. And it's just youtube.com/user/Chameleon Cloud. So we're pretty findable.
Yeah. And the key really here is that all of the things that I've shown you are real hardware. There's no software switches. There's no virtual machines. These are bare metal nodes that you're getting exclusive access to, that have 10 gigabit network cards connected to a real OpenFlow switch that you have control over. So there's nothing in this here that's virtualized, it's not using OVS virtual switches, it's real switches and stuff. So that's something there's only a few places you can have access to stuff like this, and we have quite a bit of it available.
Yeah, and maybe a last question to sort of ask in case there's anybody else who's finding the courage to raise their hand or type in a question before we close up. There's a few people here at the tail end who haven't been able to have their user account made yet, or they're not quite in the project. What's the best way for them to just sort of contact you guys after this?
Yeah, so the worst case scenario, you can just send an email to me if you want. But the best way is there's an email address. It's info@Chameleon or something like that. How does it? Where is it? It's in the about maybe.
Let's see.
FAQs. There is how do you create a ticket? What's the thing to create a ticket if you're not?
Should know this.
Yeah, I forget how to do it.
Maybe while we look that up, we do have two people who got brave and raised their hands,
Okay.
so I'm going to allow them to talk.
Sure.
So Ben Tang, you're the first person, and I'm just clicking this allow to talk. So you should, I'm unmuting you. So
Right.
you should be able to talk now.
Okay, thank you. So Paul, you just mentioned that the virtual machine is not running on those what you just demoed. But what if we want to run them virtual machines, and so that is also possible?
Yeah, if you wanted to run virtual machines, the best way is to get the bare metal node and then run the virtual machine yourself. I mean, the real strength of Chameleon is that we have a lot of hardware, and you don't need to use virtual machines because we can give you real machines. So if you really want the virtual machines, we do have some virtual machines available. They're not actually hooked up to the OpenFlow switches. But if you get a bare metal node, you can do absolutely anything you want with it, including running virtual machines inside there, or Docker, or anything you want. Is that
all right? I see. So what you just showed that, let's say we have like in my class we have like around 20 groups, let's 10 groups. So let's say each of them can perform what you just did and simultaneously, right? So in that case, there's no hardware and resource issue, and they should be all fine.
Between the two sites, there are 64 plus 30, 96 Skylake nodes that are connected to these machines. So as long as your classroom can fit into 96 bare metal nodes, then you'll be all right. Okay.
But you just mentioned the controller is on one node and the other compute node is on another node, or basically each group need 2 machines at least, or?
You need, so like for this experiment, I had 3 machines.
3 machines.
2 of them were Skylake nodes. The other one, I used one of the the older nodes.
Yeah.
But you don't even need that if you don't want to. Your controller doesn't have to be on Chameleon even. It's just convenient to have it on Chameleon. So really all you need is the OpenFlow switch that we provide, and then some number of Skylake nodes connected to that switch, and then your controller can be anywhere, including on the other half of Chameleon. And we do have plans, and we're like kind of half done with it. I know Mert, who's been answering questions, has been working on this. We want to connect the Haswell nodes to the older nodes, which are called our Haswell nodes, to the OpenFlow switches. But it's a little tricky because they have, they're a little bit older compute nodes, but they have a little bit older switches that they're connected to. But we have a trick we're going to do to make it work. But that's not implemented yet.
All right, thank you.
Okay, we have a question also from, I think, Say. I'm going to allow you to talk now and unmute you. And you should be ready.
Hi, am I audible?
Brilliant.
Yep,
there you go.
Hear you.
Hi.
Hi.
Hello.
Yeah.
Am I audible? My question is, since the switches are real, can we measure power for them? Can we access the console for power measurement?
Yes, there is stuff to do that. I don't know how to do that off the top of my head. Do you know how?
Hello.
Can you hear us? You can hear us?
Hello?
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 Hello.
Okay.
We do have power management capabilities in Chameleon.
Hello.
Hello. We hear you.
Crickets.
I think the short answer is, can someone just type it maybe?
Yeah.
Yeah.
Maybe type that in there.
And the answer is yes. Talk to us about it. There's power management available.
So who was that?
SAI something?
Okay.
SAI.
SAI. And then there's a question on questions that maybe you can see from Brian Smith. It says, do you have a mini project to suggest to make use of the BYOC capabilities and virtual forwarding context for a student who is very new to this?
So there's 2, if you want to get started, like one, like a project I think is really cool is the one that I kind of showed you that has the appliances, the security onion. If you follow, you go over here to this appliance, security onion appliance. If you go to the documentation on here, there's actually a lot of information about how to run this. and it walks you through all the details about how to do it. And this is a very cool project because this is actually allows you to do something that's not possible without OpenFlow, or without at least being able to configure the switch yourself, which is what we're using OpenFlow for. So if you go, I mean, there's a huge detail, and in the end, you end up with this GUI that shows you something kind of interesting. So if you turn this on, you actually have nodes that are on the internet, and this will actually show you attacks that are coming from the internet on your nodes. And if you turn this on, it only takes a few minutes before you start seeing them. So as soon as you turn this on, you'll start getting attacked from the internet. And if I go up to the top, what happens in this picture is, like, the attacks come from, the internet. They come in here, they're trying to attack, node 2 maybe, but you're getting mirrored traffic sent to your security onion node. And then the security onion node will present to you a website that you can go look at, and you can actually see those attacks happening live. And it's actually very cool. So that's a very, very good one. So for what you can do if you were to run this complex appliance on Chameleon, you would actually get a Ryu node that looks just like this one that I set up, except, let me go back here. I showed you this Python file here that is showing the OpenFlow, like how the OpenFlow is implemented. The only difference between the controller for that security onion project and the basic project is this one Python file. And if you were to compare the Python file in the simple example that I showed you with the Python file in the security onion example, you can see the differences in how we modified it to do the mirroring. And a really cool project would be to have students try to do the mirroring. Yeah. Although the answer is on the website, so I don't know, maybe it's not that interesting.
Excellent. Well, on that note, that is kind of the end of the question line. We did kind of resolve the issue about where to go and make a ticket, which is the help page, which is quite logical. Yeah. But I do think everybody's like very open to following up on this webinar and helping sort of individually for different projects. But since there's no more questions, I'll just say thank you, Paul, for presenting today. And thank you to everybody in our audience for being here and asking such good questions and following along and participating. I think this is always a lot of fun for our team. So thank you for your time. And we do want to also make sure that you know to join us on November 14th for our troubleshooting webinar called Share Your Troubles, and we will shoot them. And then I think maybe this audience might be a little more advanced in Chameleon, but if you happen to know some newer people who are interested in or should be interested in learning about Chameleon, we have an introduction to Chameleon webinar on October 8th. And they're all at this 3 o'clock to 4 o'clock Eastern time window. So thanks, everyone. Have a great day.
Cool.